Hello students, so let's discuss the rest questions. I am going to discuss today from question number 11 to question number 15, which came in GATE 2014 paper of mechanical branch of 1 mark each. Okay, so let's start with the 11th question. Gear 2 rotates at 1200 rpm. This is actually the gear 2 given. This figure is given in the question. This is gear 2. Here it is written 2. It is having 20 teeths and it is rotated with 1200 rpm in counterclockwise direction, and a direction is also mentioned in the figure, and engages with gear 3. This is gear 3. This bigger circle is gear 3. Gear 3 and gear 4 are mounted on the same shaft, as you can see in the figure. Gear 5 engages with gear 4. Okay, the number of teeths are mentioned in the figure itself. You have to find out the angular speed of the gear 5. Okay, so it's a very direct question. If you want to write the gear ratio between gear 2 and gear 5, so you can write N5 by N2 is equals to T2 into T4 divided by T3 into T5. Okay, so after substituting the value of the number of teeths, you will easily get 300 rpm. Now how to check the directions, because both the options are there, 300 rpm counterclockwise and clockwise also. So this gear 2 is going to rotate with counterclockwise direction, so gear 3 with clockwise, so gear 4 also with clockwise, and gear 5 with counterclockwise. So option A is correct. Okay, now let's go to the next question. Consider a long cylindrical tube of inner and outer radii Ri and Ro and length L and thermal conductivity K. Its inner and outer surface are maintained at the temperature Ti and To, where Ti is greater than To. Assuming one-dimensional steady-state heat conduction in the radial direction. Please be careful. Here the heat conduction is taking place in radial direction, and that too one-dimensional and steady. So we have to find out the thermal resistance. Okay, so we know, as per the Fourier's law, Q is equals to minus Ka dt by dr, or dt by dx. X is the direction. Okay, so here A is the area from which the heat transfer is taking place. So this is the surface area of this cylinder. This figure is not given in the question. I have just drawn to explain you in a better way. Okay, so area is 2 pi RL. Okay, now here R is not constant, it varies from Ri to Ro, so you can easily take minus K into 2 pi KRL by dt by dr, and you can integrate it from Ri to Ro, where the limits are T is equals to Ti at R equals to Ri, and T is equals to T naught at R equals to R naught. So you will get this expression. Okay, so if you will convert it in a general form as heat transfer is equals to temperature difference divided by resistance, thermal resistance, so this is our answer. Okay, so you will get R thermal is equals to ln R naught by Ri divided by 2 pi KL. Please remember this. This you can use it as a direct formula in case of a cylinder. Let's see the next question. So this is the question from thermodynamics. Which one of the following pairs of equation describes an irreversible heat engine? Okay, so actually this question is a very straightforward question. You should know the definition of Clausius inequality. Okay, so Clausius inequality or Clausius theorem is for irreversible heat engine. I have mentioned here, see, a cyclic integral of del Q by T is less than equals to 0 for irreversible heat engine. Okay, so you can easily eliminate two options, C and D. Now the point comes, which option is correct, A or B? So we can easily say for a heat engine, whether it is reversible or irreversible, del Q is always greater than 0. Del Q is basically heat supplied minus heat rejected. Okay, so it's not at all possible that by giving more heat, means by rejecting more heat, or del q cannot be negative in any case. Okay, so it is always positive, and del q by t is cyclic integral is less than equals to a less than 0 for a irreversible heat engine. This is a Clausius inequality, so option A is correct. Okay, now let's see another question. Consider the turbulent flow of a fluid through a circular pipe of diameter d. Identify the correct pair of statements. The fluid is well mixed, the fluid is unmixed, Reynolds number is less than 2300, Reynolds number is greater than 2300. So we know that Reynolds number, when it is greater than 300, it is a turbulent flow or a mixed flow. Okay, not a turbulent flow but a mixed flow. Okay, so 4 and 1 are correct. And if so here option D is correct. I have also mentioned here, see, Reynolds number greater than 2300 means it is a turbulent flow. In a turbulent flow, the fluid is well mixed. The fluid is unmixed for a very low Reynolds number laminar flow. Okay, you cannot say that a Reynolds number is less than 2300 and it is fluid is unmixed, because very less, it should be very less from the from 2300. Okay, now let's see the last question, question number 15. For a gas turbine power plant, identify the correct pair of statements. Remember guys, gas turbine and steam turbine, actually in case of a steam turbine there is a boiler as well as a turbine. Okay, and in case of a gas turbine, there is a turbine and a compressor. There is no boiler in case of gas turbine. Okay, so see, I have written here, steam power plants are bulky due to the presence of boiler and condenser. Gas turbines are compact as compressors and turbines are coupled on a common shaft. In a steam power plant, boiler takes a lot of time. It's a natural thing that if you want to boil something, okay, so it will take a time, it will take some time as compared to the gas turbines. Okay, so which of the following statements are correct? So we can say for a gas turbine power plant, it is smaller in size compared to steam power plant. For same power output, it's absolutely correct. Starts quickly also because there is no boiler in case of gas turbine power plant. Okay, works on the principle of Rankine cycle and good compatibility with solid fuel. So we know that steam power plants, gas turbine power plants works on a principle of Rankine cycle. Okay, and means if you will okay, I'm sorry, actually this is option Q. Okay, so PQRS, here I have missed the Q option. I have to write Q here. So these two are correct, P and Q are correct. This is wrong actually. Steam power plants works on Rankine cycle, not gas turbine power plants. Gas turbine power plants works on Brayton cycle actually. Okay, so P and Q are correct, so option A is correct. Since R and S are, R is 100% wrong, so all these two options B and C are eliminated. S is also 100% wrong. Why? Because in case of gas turbine power plants, you cannot use solid fuel, because gas turbine power plants are generally used in aircrafts, and solid fuel as it is heavy, so the efficiency is very low. Okay, with solid fuels. So P and Q are right. Okay, so the rest of the questions I will discuss in the further video, students. Thank you.